Okay, so my screen is visible and my audio is also clear.
Yeah,
Hello? Yes?
it is
Okay,
visible.
okay, we'll just start the- Okay, so today we are going to study time series analysis and forecasting. Now let's start a little bit about what we have discussed earlier. We have discussed about regression, correlation as well as regression. So where we studied about correlation, we studied that correlation is a relationship between two variables x and y, and regression is when we try to regress variables, and that is used for prediction. Now it has been a lot of cliched in economics that every time we try to figure out something, we use regression. However, if we move on to the supervised learning and the unsupervised learning processes, which most of the today algorithms follow, then regression is one of the lesser used predictive model than the time series, because whenever there is data, there is dates, and data is saved in a database with date column. So considering this, for supervised learning, mostly we use time series methods, and for unsupervised learning, we go with our cluster analysis and regression analysis. As we have theoretically studied that a time series is collection of IT function such that t is equals to 1 to n, where t represents the interval, the time and interval between yt and yt plus being fixed and constant. If you do not understand the technical jargon, it's absolutely fine. We'll be discussing it in our upcoming slides. So it is a series of observation taken at a specific time at equal interval. It is used to predict future values on past observed values. Again, a little bit of more background about the statistical technique, which is used to analyze data points collected or recorded at a specific time interval. While time series analysis and forecasting focuses on analysis of a single time dependent variable, the multiple variate time series expands to its concepts and consider multiple time multiple time dependent variable. I'll just give a quick example over here. So, see, if there is time, suppose January 20, February 20, January 20, February 20, March 20, and so on. And then there are variables. Now, the variables can be of sales, of income, of any prediction that you want to take into consideration as per your data. So, suppose there are variables 2, 8, 6, so on. Now, this is a time series data. Okay, we have got time as well as variable. Now, moving on to the next thing, when we have many variables and different sort of times, then that would be our then that would be our multivariate time series data. And when we have time multiple times in multiple variables over the rows and columns, that would be our panel data. So this can vary. We'll study the multivariate and time series and panel data in our later classes, or maybe in another course, because this course is limited to the time series analysis and forecasting. Moving on to our next slides. Just let me erase this. Pause. We have also technical theoretical foundations and mathematical derivations. A lot of stuff is there, but for now we'll just cover the practical aspect of it. And just stopped. Okay. Now, the question is, why do we study time series? So it's basically used for visualization of data, understanding a relationship between variables X and Y variables, capturing the temporal dynamics and forecasting and predictive models, and also to understand about the outliers and anomaly detection. Again, everything cannot be covered over here. So outliers and anomaly detection is something that I assume you already know, and if you don't know, then we can obviously discuss that. Now let's understand the components of time series. So there are basically four components of time series: trends that is represented by TT. Then that is basically the time trends. Then seasonality, that is the seasonal fluctuations. Normal example is like summers and winters. So it is represented by ST. And cyclical fluctuations, which depends upon the business cycles, that is profit high and profit low situations, and that is represented by CT. I'll give a little bit about it in the case study as well. And then there are irregularities, that are the patterns that are not really regular. So time series have some of the properties that is required to be understood before we move on to the proper time series data. So first of all, we consider that time series data have autoregressive time series data is autoregressive. It's like it's a model to predict, like it is predictable on the basis of past values. Like it can be of linear combinations, it can be of random errors, and then we minimize the random error, and we can also basically it's OLS related or related to ordinary least square. That is something that can be discussed for if we are studying the proper autoregressive systems, where yt has beta naught plus beta naught plus beta 1 y plus beta 2 y. Over the time period, the interval is considered to be fixed. And then there is epsilon term, which is the random error term. So there can be, then there is moving average, which is a separate model that is used to predict the past and the future values. And then there is other seasonal dynamic processes, like, so basically we have AR, we have MA, then we have integration of ARMA, that is ARIMA model. Then we have changes in this models like linear predictability model, then there is Grach model, then there is Ganger's casualty test for the various test of stationarity, which we will discuss in the further further upcoming slides. Now, because time series data is ordered in time, so past value influence the future. This is the autoregressive thing. This often results in violation of the assumption of no serial correlation in the residual of standard OLS model, that is ordinary. So stationarity test is something like, in general, what is stationarity? It's stability, right? That the data is the data is not having some of the properties which should be same, like mean, variance, standard deviation. So this is something that we use to season out the seasonal variation, any type of variations that occur. So let's see. To save time, I did already prepared the discussion bar. So I'll just start. So see, if there is any company that has, obviously company would be having a database. Now that data would be based on times, and time can be predicted through sales. So what do we do of dates? We index dates, and for sales we can code them to items. Now whenever we plot a data, something of a data of some this sort may appear to us. So if I would calculate the mean of this part and the mean of other part, that would not be equal. So this is something that says that the data is not stationary. So obviously, what kind of data is this? Suppose we have January 23, February 23, March 23, and so on up to. So we have got this data. This is time series data because 1 month ka interval hai. We have that 1 month interval, January to February, February to March. So the difference between the two data points is constant. So we can say that yes, if we want to predict the value of January 24, we can do it. Now, suppose if we have another data that is like January 1, January 20, February 23, and then March 23, April 23, so on up to, and then we have sales. So, yes, this is a time series data. But this data cannot be predicted because this data does not have that constant time period or constant interval thing. Now, moving on to our next thing, if we talk about the data analysis, this we already discussed. So if we see over here, our mean would be something around like 50-55, and here the mean would be something lying between 150 to 200, any value over there. If we So for this, we need to do some of the properties that should be equal that we discussed: mean, standard deviation, and variance. Coming on to, we already discussed that we have a data, and then then data has to be processed. For this, yes, sir.
Yes. I like to know that is, you have written auto-regressive. So from your data, how can we understand the auto-regressive model?
Yes, sir. So for auto regressive model, when we talk about the autoregressive model, we have various methods to understand that if our data is autoregressive or not.
For that reason, which will be the prelude for autoregressive model, whether autoregressive model will be appropriate in my data or not. For that reason, is there any prelude
Is there any?
or any assumption, pre-assumption that this data will be this type of then autoregressive model we can apply?
So normally we consider the stationarity assumption only because for when we start with our time series data, the first test that we conduct is for stationarity. That if the data is stationary or not. Then for that we have got various methods like mm, Dickey Fuller test, unit root test, then there is this casuality test as well. Then there is plot test where we just not recommended, but yes, we do just see the data, and if we see that these properties are not uh, not same, then we can say that okay, this data is definitely having seasonality, or is having its highs and lows. So so that means that our data is not stationary, so we need to perform the test for stationarity. Also, we can decompose the data, and we can divide the data between mean and standard deviation, and then we can understand if the plot is showing any kind of autocorrelation or not. And then accordingly we can perform for autocorrelation, we perform the Durbin Watson. No, for gold. So there are like four properties: homoscedasticity and autocorrelation, for which we have different criterias, different tests. which we can find online or in Damodar or Baltagi. These are the references that I normally follow. Then there is also the AIC criteria, for which we see that is the test fitting the model or not for autoregression itself. Similarly, there is like Bayesian criteria as well. So, or we can also go on for the partial autocorrelation plot, where we can understand that the autoregressive criteria is met or not. And then moving on to moving averages, we can just plot it and see if the average is something very simple that we have studied again and again since class, like uh, class 8th or class 10th. We study how we compute. So this is moving average is very basic method that we also learn before learning the indexes, like price index, quantity index, then Fisher's index and past chase index. These all the things we learn in time series itself. But before that, we understand the concept of moving average.
Okay.
Other assumptions I may not be awa- uh,
Because you
aware.
have written autoregressive, ARIMA model.
Yes, so there is analysis. Normally, if we go into the econometric analysis, it considers linearity to be one of the pre-requirement, independence of two variables. So autocorrelation must not be there. Variance should be same or zero, something of that. No multi-collinearity should not be there. So covariance is to be zero or some zero or one. I'm not sure, but we can check that. So these are something that is used to check if the data is valid or not. Also, one thing that is very important for the robustness is that there should not be any missing values. There should not be any duplication of values. And for treatment of missing, duplicate, or ambiguous values, because sometimes there is like for number of students they have in UDICE's data only they had put number of students and the variable part was chairs. So how can number of students for males be chairs and female be tables? So these kind of things we need to check, and that we can check by just a control find function in Excel if we are doing a data cleaning in Excel. Otherwise, if we are using the Kaggle data, most of the Kaggle data is free from these kind of problems. But then also it's better to cross check. Then our robustness would not be there. We Our stationarity would not be there if we check in SPSS R or any of the Stata software. Then that would be displaying that our data is not non-stationary again and again. So I guess uh, that is something
Okay, now
that
continue.
addresses.
Continue.
Yeah. So when we talk about the sales data, the sales data and the process over here is initially again we need to test for the stationarity or the stability of data. Now for the test of stationarity, we as discussed already, we have already various methods to do that. The visualization or the plot function, the p-values which we can also do for the significance. For basically in basic statistics also for significance of test we use the p-values. And then other is the confidence intervals, where we see the results with the confidence variables, and if it is close or not, that's already provided in the descriptive statistics, which is available in Excel also. And then the descriptive statistics normally provide this. So again, we have this first test that we study for the basics is the unit root test itself. In the unit root test, we have two hypotheses. The null hypothesis that the time series is not stationary, and this is also known as the hypothesis of no difference. Alternative hypothesis, where we say that the time series is stationary. This is also known as the hypothesis of difference. I'm assuming you have a good background in statistics and you know what kind of errors occur if there is if we accept the null hypothesis instead of alternative hypothesis. Then there is the error that may occur and our results may not be accurate or valid. So again, there is another thing that we do for
Please
not
change the
specific.
slide, Dokshita. Change the slide.
Yes, sure. So we have,
Slide is same.
okay, we have, I was going, okay, let's understand about our types of tests that we can use. We can use the AR model, the MA model, then AR-MA model, which is autoregressive and moving average. ARIMA integrates the both. Then we have different models like Facebook profit model, Facebook neural profit model, which is the upcoming models, the LSTM models, GRUs, and seasonal ARIMA models for SARIMA Max, PD ARIMA. There are various methods, but for this, we'll only discuss time series data and the ARIMA model because we need to understand how to do the tests. So before that, we'll do the exploratory expl EDA analysis, that is exploratory data analysis. So I'll just move on to the slides of the exploratory test of stationarity, ARMA properties. Didn't I entered the exploratory data analysis? Okay, so we have a lot to discuss. What we can do is that we can do the EDA part in some other lecture. First, we'll understand that the R software codes are all provided in the Google Classroom. The first step when we try to understand the R is that we need to download the library files, all the related library files that are required for the course for our data. Second, we have to make that format is in CSV form because that is more appropriate rather than converting and then exporting and importing and then converting. Thirdly, we need to make sure that our data is clean and error free. What do we mean by clean and error free? Is that there should be no missing values, there should be no extra variables, there should be no extra rows or columns. Data should be uniform, and we need to check the data for all. There should be data for all the variables. And then there are methods. If we have some missing values, then we can obviously use some of the methods available to get the predictions. Like we can extrapolate the data, we can interpolate the data. So these are the methods that are available. Indexing of dates in arrays is very important. I'll explain to you how to do that. Then plot the time series to check for the stationarity. Then stationarity of data to check, there are various methods like unit root and then Dickey Fuller tests and various methods. And also remember, if sometimes you need to apply the transformation to the data, then you need to convert the data by inversing the data. So let's move on to plotted line. Plotted. See, if this kind of graph you have, then you can obviously see that here the mean would be less. It would lie between 100 to 200. And here the mean would be between 500 and 600. So if we divide the data into three parts, then three parts would be having three kind of different means and variances. By visually, we can say that the data is not stationary.
Akshita, you are not showing the slide.
So which slide?
It's a blank.
No, so now is it showing?
Yeah, yeah.
So suppose we have got the data. We have to extract, convert of data, say related to sales, items, or passengers. And so here is the data of the monthly data of passengers travel for a specific time period. So we need to understand that the time period between the two variables, the time period should be constant. And we can check for seasonality by plotting the data. Here also, if you see, the maximum variable is 40. So we can just understand it. Now, next step is to check for stationarity. So what we would do is we would the command the mm, software or any software that you are using to consider the test for stationarity.
Are you
And
using
why?
any standard, any reference? Are you using any reference for the comparison purpose?
So that was to be discussed in case study. But if it is like creating a little bit of problem, then in understanding, then what I can do is I can just share the case study right now itself, the reference data.
Okay.
So yeah, that would be absolutely fine with me for Arima itself. So here we like here is initially here is just a review of introduction and just review of literature. That was supposed to be the initial first project of the students. Like where a time series, this is something that I was going to explain, like how to do review of literature and then start with your putting your point forward and getting proper references and what should be there in a research product project and what should not be there. And how we cannot, everything that we have in our review of literature we cannot put into our research project. So why are we doing time series analysis, and what are the models that we need to put it in a chronological order, like autoregressive model was given by Thomas, and then there was more research, and then they realized that okay, we need something with moving averages as well because it gives a better protection. Then we moved on to the broken line and box and Jinkin, and how people came up with no, Arima and box and Jinkin methods are something that gives us equivalent result, and everything how we present it in a review of literature, and why how can we move from this Arima and all these models to the KNN model, which is the nearest neighbor algorithm for KNN parameters. Then how can we just a little, then what is the methodology for everything, which we go about the process that we download the data from Kaggle and do the EDA analysis, the exploration. So this was the chart, and these are the various softwares for auto correlation. Sorry, for Arima, auto Arima model, best is R software. NumPy and Python may not give us as appropriate results as R, and these are the methods for prediction and linear regression. Then how we put the codes for data set, and how we observe that okay, this is the data, that these are the seasonalities in trends. and item price and number of sold, then we can just quickly see if there are any outliers present in the data by putting in the commands in any software of your. Then we have PDQ, where P stands for ARI for integration, and Q for average part, where AR model is there if P is 1 and DQ comes to be 0, and if there is only Q data available, then that is an MA model. Then AIC is the measures of statistics that we use to see if the data is fit or not, and BIC is also there. Then we have to implement, before implementing, of course, we have to do the unit root test or the Dickey Fuller test, and these were the seasonalities that I was going to discuss: the trend, the cyclical, the seasonal, and the irregular component, the additive and the multiplicative part. This is the decomposition of the data that can tells us beautiful charts are available for this, and we can give our predictions. Then the code for testing of the stationarity, and how if it is 0.14, then this is less than 0.05, then we accept our accept data is stationary. For critical values also, this lies between 3 to somewhere on the 3, uh, like near to the critical values. And once we have achieved the stationarity, then we put in the code for doing like, do we need a lag, or we do not need a lag. It would mess up with our stationarity, and it would so then we plot a diagram, and this is the results for ARIMA, where we say, okay, it can be clearly seen that red lines, which is forecasted by ARIMA, has almost acquired the same blue line, which is differential series, and now it is fitted. And then we say, okay, seems like it has given us this is the best fit model, but maybe the results are not well predicted. So we may move our data, like we test for stationarity. Different tests are there when we do log and we transform, and then we inverse the model until and unless we find the best stationarity. Same we do for our research. We need to understand which model is to be fitted. If ARIMA is not there, then we will move on to our next model for extreme gradient boosting model, or any other of the models that would best fit. So I was trying to explain it with Excel so that they know about the first transformation of log, then difference is like b4 minus b3, and then moving average can be computed and all that stuff. Yeah. So I guess that's all for
This
today.
is for forecasting.
Sorry.
This is for forecasting.
Yeah, for forecasting, for fitting
Uh-huh.
in the model, and then forecasting would be next step. So
Okay, okay.
forecasting may not be the part of
No, no,
this.
no, no, no. Forecasting is not required.
So yes,
Okay,
so
thank you, Akshita, for sharing time series analysis, and
yes,
you have explained the time series analysis. And this is my observation that when you teach any particular new concept, then you have to use the you have to use the art studio. If you can use the art studio, then you can get very beautiful plot. So now I am requesting Farah. Please, Farah, share the screen now.
Sure, sir. Just 1 minute.
stop share.
Uh, Now in behavioral science, when you want to follow the time series, then you have to consider some psychological factor also. Otherwise, you may not be able to classify or to provide some support. Now, Farah, please.
Yes, sir. Just one.
Yes. So this is the monthly consumer spending. Another one is the across the year. Now, here you can find out that is the after 23rd monthly consumer spending that is less in 2024. 2025 little bit high. But if we want to collect again, maintaining at least 1 year gap between husband and wife, then then both of them can uh, maintain their quality of life in better manner. Therefore, you have to pay attention to the psychological variable. Now go to the data, Farah. Yeah, here you can find out the income, spending, then savings. After that, you will find out that is the bias score. So this bias score, that is the psychological data. And these psychological data may affect the income pattern, expenditure, savings pattern. We do not know. And for that reason, you have to create the data frame. For a go to above, where you have done the R data frame. No, no, you go up. the library. No, no, you go above. Uh-huh. So it is, the vector is time and it is sequential. So this is the date and by month. Since data will be randomly generated, therefore it is written income round R unit. Like spending also the same. And savings equal to income minus spending. And the bias code that is also written, R unit. And bias code from 1 to 10. So again, it will be the random generation of the item. And next, that is your data frame. That is called the behavioral economics. That is your data frame. This data frame include time, income, spending, savings, and bias score. Next, you have seen head behavioral economics. Next is spending TS. TS means time series. So this is the time series. After that, plot the time series. And when you write the plot, the time series, then you will get the plot. So to make the plot, you have to follow this R script. Okay. Okay. Thank you, everybody. So this is all about the time series. If you have any question, please you ask in the WhatsApp group. Thank you, Akshita. Thank you, Farah.
Thank you, sir. Thank you, Akshita.
Thank you,
Now it
sir.
will be available in YouTube. So please